Next point is stick diagram. Now what is meant by stick? Matchstick, sticks, so it is like a stick. So after the completion of this particular lecture, you will be able to explain capabilities and limitation of stick diagram, what is meant by stick diagram and its capabilities and limitation, and you will able to draw the diagram for any CMOS circuitry, this stick diagram for any CMOS circuitry. So this is the stick diagram. Now you are able to see some colorful diagram. This diagram we are implementing on microgrid. Okay, first practical is of inverter, CMOS inverter. So you know that PMOS and NMOS connection for the inverter, as we have gone through it in the last PPTs. So that network you need to implement, and for that network you need to draw the drain, source, gate notation properly, as I told you earlier. So what is stick diagram? Stick diagram is a cartoon of a layout. So this is the stick diagram. What is inside it? That is mentioned over here. So this is what you have diagram for the inverter you have drawn, which we are having pull up network and pull down network and input X. And as this is the inverter circuitry, you will be getting complemented output, that is X bar. VDD, ground, input, output, each and every notation writing is very important. If you are not writing it, the marks will be cut. So here, what is stick diagram? Stick diagram is what? Is the drawing in terms of sticks. So here you are able to see some color and some line. Again there is different color, again there is different color. So each and every color is having its own significance. Now you will tell that in paper, as there is no that writing paper will be now because of this COVID situation, but if you need to draw, how you can draw? So you can draw by your normal pen also. There are some notations available that will also I will be telling you. So hope you understood that this diagram we have seen, and this we are implementing on our microwave. In between that, whatever is having is the stick diagram, and this color are very important, which is playing very important role. So VLSI design aims to translate circuit concept onto silicon, because I have drawn on the paper, but I need to fabricate that particular device. So to fabricate that device, I need to finalize W/L ratio, what is the width of that source, drain, connection. So everything I need to do. So I need to draw this microwave diagram, and because before that I need to draw, to simplify this circuitry, I need to draw this intermediate diagram, that is the stick diagram. It is in the form of sticks only. So this is theoretical concept, and you need to draw the things practically as well as the on book. So stick diagram are mean of capturing topography and layer information. Now, as you know, there are many layers present. So that if that will be overlapping to each other, so it will get connected. So for that reason, we have used different colors for different metals. So this color is the different metal, this is different metal. Likewise, each color indicate different metal, so that there will not be connection between every layer. Okay. So stick diagram convey layer information through color code. So layer information, as I told you, one above another. If you are having the circuit diagram, and if that will get connected, it will be difficult to trace. So that is defined in terms of color. So it is act as an interface between what? This symbolic circuit and this actual layout which you are implementing on microwave. Okay. So these theoretical things you need to remember every time. Now what is does and does not? So what stick diagram does? So it shows the component. That what is meant by component? This is one PMOS and this is NMOS. So this PMOS is defined by this particular structure. You are able to see this blue, this orange, and this red, again this blue, orange. So this is actually diffusion. Suppose this is a PMOS. So which diffusion is there? P plus diffusion. This is what is red color. This is the polysilicon, which is the gate. Again, this is the diffusion. So this is source, this is gate, and this is drain. And to connect that with your VDD, we have used this particular different metal to connect. Okay. So here it shows all component, and that's why here this is one component and this is second component, which is shown over here in the stick diagram. This is my first component, second component. In the coming PPTs, you will understood it better way. Okay, it shows the relative placement of component. Relative placement means I am not saying the exact placement that this transistor will be there only, but relatively I can say that if PMOS will be connected in pull up, this will be in pull down, and they are connected in series like this. Okay, both one step closer to the layout. As you know, this is one step closer to your layout. Okay, so helps to plan the layout and routing. If I know where to place which device, so I can route it in the effective way. So this is the thing. Now, it does not show what exact placement, that exactly this will be lying over this portion or not, that is not shown by the stick diagram. Transistor sizes. Transistor sizes means it doesn't mention that what is the W/L ratio of the transistor. Okay. Then wire length, width, this is not shown by the stick diagram. Any other low level details such as parasitics. Parasitics means inside I have told you that there are some capacitance present. So this is not, that information is not shown by the stick diagram. Okay. So what is the notation? So I told you, if you are drawing on the paper and if you don't have color pens, so what to do? So here metal 1 is shown by blue line. Polysilicon is shown by red. Always polysilicon means it is used for gate. Previously aluminum was used, but now we are using this polysilicon material for gate. So here it is shown by this black line. Okay, and here it is dotted line. So these are the notation for drawing by normal pen, and these are the color notation. So polysilicon is defined by this red line. So here it is red, means it is the gate which is used using polysilicon material. N plus diffusion. Now what is meant by N plus diffusion and P plus diffusion? That already we have gone through the concept of this P type MOSFET and N type MOSFET. So I told you this is what N plus doping. Suppose I am having N MOSFET, so I am having this N plus doping over here and N plus doping over here, and this is my P substrate. Over here there is a SiO2 layer and oxide and silicon dioxide and gate. So what is meant by this N plus means I am considering this two N plus region, means this is the N type of MOSFET, N channel MOSFET. Now I required one source, I require one drain, and I require one gate. So here if I am using this particular color, that is green color, like this. Okay, so this is my P N diffusion region. Okay, I'm just want to fill the things, but this, suppose I have filled the things. So this is what is my material which is forming N plus material. So now in after that what I required, I need to form a gate. So gate is of what? Polysilicon material, and that is what is a red color. So I am taking one red color and I am putting that over here. So what is this? This is my gate, and source and drain are interchangeable because they both are of N plus diffusion. So I can mention this as a source or drain and this as a drain or source. So this is my transistor. So if this particular P diffusion I am using, sorry, N diffusion I am using, which is of this green color, means this is what is a N MOSFET. In I am using, suppose this P diffusion material, then it is a PMOS. Okay. So hope the things are clear. Again in the coming PPTs that particular part will get clear. So here you are able to see W/L ratio, where this is what? Diffusion. Which diffusion material? That is the N diffusion. So this is my N MOSFET. Okay. If that color is of this color, then it is P MOSFET, because red color is for the polysilicon and this green color is for N plus diffusion layer. Now, as we are saying that we are increasing the W/L ratio for match up the current flowing through the devices. So we are increasing the W/L ratio of P MOSFET. So how to show that? Although it is shown in terms of this N MOSFET only, but you need to understand what you are doing. You are changing this W, that is the width of your transistor. Okay. So this is NMOS, which is shown by this N diffusion, which is shown by this green color, and this red indicates polysilicon. So this is my source, gate, drain. Again, I can say this is drain, source, gate, because source and drain are interchangeable. Now, if I need to draw the PMOS, how to draw? In PMOS, P plus diffusions are there, and it is denoted by this color. So we have taken this color, and in between that, one gate is placed. So this is my PMOS. Okay. So over here, in the same way it is mentioned. Now you can define the things in different way. I'm not going in detail of this shared gate, What is meant by shared gate actually? Here, this is what is the PMOS, and this is what you are able to see the NMOS, because I told you this is for NMOS. You need to take this particular thing, but here they have done differently. So this is my N MOSFET they have mentioned, and this is my P MOSFET as per the color combination given over here. Now suppose I need to combine the gate or input of two. So what I need to do? I need to connect gate with each other. So in this way, gate of both the transistor will get connected. So here is the shared gate concept, you can say. Again, horizontally also you can draw the things. Okay, and this is the concept of shared drain and source, because this is what, suppose N material, so this is also N material, this is also N material, and this is also N material, meaning of that these two transistors are in series. Okay, I'm not able to draw it properly. So what is this? This is suppose a source, this is a drain, this is again a source because this is N type of transistor suppose, and this is drain. So this is my gate 1, and this is my gate 2. Okay, so just see, this is a N plus material, so I am naming it as a source. Okay, this is what drain and source are connected because this is material is N plus only, so this same material is there, and internally they are connected. What is the connection? Drain is connected with the source of second transistor, so I can say connection, and this is what is my drain of second transistor. So in this way also, if you need to provide the series connection, instead of taking two transistor, you can show in the shared drain or source diagram. Okay, vertically and horizontally it is shown. You need to go through it because there is vast thing over here. Now rules for this, very important. Now how you will understand whether the transistor is drawn or different connections are drawn? So first rule, now this, you know, there is one, this is metal color, metal one color, which is shown by blue, and this is some polysilicon material, but I am not saying this as a gate because every time that material is not used as a gate. Okay, so when two or more sticks of the same type crosses or touches each other, means there is an electrical contact. Meaning of what? If I am having same color, I have taken one color, that is, this is for one particular type, and I have just done like this. So these are internally connected. But if I am taking like this, so I have drawn this, but I am taking another color, which is blue, like this. So although you are able to see these are connected, but they are not connected, they are only one upon another. So what is the meaning of first rule? That if same color sticks are crossing each other or touching each other, means there is an electrical contact, means they are connected to each other. Likewise, this is the red color line stick and red color stick, so they are connecting, so they are not above each other, but they are connected, electrically connected. Now what is second rule? Now if you are having two different color stick, so this is one color and this is second color, so although you are able to see that these are connected to each other, but still electrically they are not connected until and unless you are not making contact like this. You are not making contact like this, it is not connected. Okay, so same over here, there are two sticks were overlapping, but they are not electrically connected. Until and unless you are not making contact, it will not be connected. Okay, so going to the next PPT. 4 rules are there. Now see. Now as I told you, in transistor, if I am having a green color, okay, so if I am having green color, it is denoted for the N plus diffusion. Okay, N plus diffusion. And what is gate? Because this is my N plus diffusion suppose, and I need to draw the transistor. Okay, so I need to draw gate because this is my source and this is my drain suppose, because both are of N plus diffusion. So I need to take which color? That is red color for gate. So if I'm placing like this, so these are not connected because red line is over that green, but they are not having contact, so electrical contact is not present. Then this is acting as a transistor and MOSFET. So here it is mentioned that is green line and red line crossing each other, it forms a transistor. Which transistor? N MOSFET. Okay, but if I am putting a dot over there, so it is not acting as a MOSFET. Same over here. This is what is the P plus diffusion layer, and this is what is the gate. So here this is acting as a P MOSFET. But if I am putting dot over there, means there is an electrical connection between them, and that's why it will not be acting as a transistor. So this, keep the note of this. If a contact is shown, then it is not a transistor. If the contact is shown, it is not a transistor. But if you are using proper diffusion material and metal, that is gate for the gate, then it will be a transistor. Okay. Now last rule. Now always, you know, PMOS should be connected in pull-up network and NMOS should be connected in pull-down network. So to separate out the areas of PMOS and NMOS, there is one demarcation line. So this dotted dash dot dash dot, this line indicates demarcation line. This is called as a demarcation line, where it indicates above to this you need to put your P MOSFET, and below to that you need to put N MOSFET. Okay, so hope you have understood. This is called as the demarcation line, and as dot is not there, means this indicates your PMOS and this indicates your NMOS.